And so we have shape, but that's not the only way you do this. You can also classify them by layers. And the two main categories are simple and stratified. So if you've ever taken any sort of like earth science course, you might have heard of the term strata. So strata refers to layers. So the cool thing is that epithelia, what I showed in the previous example were simple epithelia. But what we have here are stratified epithelia. And what you notice is that, hey, they also can combine with those three shapes. So we have stratified squamous epithelia, stratified cuboidal, and stratified columnar. What's the big difference between this and the previous example? Well, in the previous example, we only had one layer on this basement membrane. But notice that in this squamous, we have multiple layers, cuboidal, we have multiple layers, columnar, we have multiple layers. And this is where it can also get confusing. You might be like, wait, aren't these cells pretty flat, but these cells over here looking pretty cuboidal? And over here, these cells over here look pretty, on the apical side looking more columnar, but the ones toward the basal side, they look a little more cuboidal. Well, this is where it's easy to get confused, but notice that when you go toward the basal side in the stratified layers, they tend to look more rounded. It's only when they get pushed up toward a surface that they start to take their actual shape. So when you're looking at these type of stratified layers, don't get confused by the differences between the apical and basal side. You should be looking at the apical side of these layers. So when you look at the part that's furthest away from that basement membrane, notice that over here, these are flat, these are cuboidal, and these are columnar, so don't get confused by the basal side. Look at that apical side of these epithelia. And that's what we see here. So here we have real H&E staining and tissue samples. So this would be the basement membrane over here. And you notice that, yeah, these look kind of cuboidal, but this is the part that's actually facing some sort of surface in the epithelia. So notice that these cells over here, the nuclei are very stretched out and flat. And cuboidal, well, it's pretty much like, yeah, they look very round and they look about the same in terms of their height. And it's interesting too, like basement membrane isn't just always a flat sheet. Sometimes you can form these little tubes or ducts. So the basement membrane would actually be circular in this example over here. But notice that the apical side that faces toward the inside of this tube, this is pretty roundish. And I know it's kind of hard to see, but don't worry about being a histology expert at this level. Now columnar, this would be the basement membrane over here. This is the surface, and notice that these ones, again, this is basal side, this is the apical side, and notice that the apical side is taller than it is wide. So again, if you see in multiple layers, don't worry so much about the basal side, look at the apical side, and this is how you classify the shape. So again, you can not only just classify based on shape, you can also classify based on how many layers. So pretty much if it's one layer, it's simple. If it's two or more layers, it's stratified. So stratified, multiple layers. As long as there's more than one layers of cells, then it is stratified. And why would you have stratified? Well, you also have more protection and also more cells. Because compared to just a single layer of cells, the more cells you have built up, the more protection you have against something that maybe something that scrapes against the epithelia, or in terms of like your skin, and also your GI tract, also defends against pathogens and things that can cause disease like bacteria. So the cool thing about stratified is kind of like constant turnover, meaning that you can regenerate. So the cells, the one common feature of many epithelia is that you can regenerate these cells and layers over time. So the cool thing is like from the basal side, you're always putting a new layer of basal cells, and it keeps on pushing the older layers up and up and towards the apical side. So this is another reason why epithelia tend to shed over time. As you push the basal cells start to grow and push more and more layers further away from the body, these cells start to die off and slough off as well. Now, this is an exception. So transitional epithelia. So transitional epithelia, I want you to think not just a layer, but a stretchy layer. And you find transitional epithelia in your urinary system. We cover the urinary system more in detail later on in PHYL 142, but at this point, you should know this is where you tend to find them. So this is why your bladder is able to contract and expand. It has some stretch to it, but why isn't it squamous, cuboidal, columnar? It definitely is stratified. But notice that when it's relaxed, that these cells are kind of like, okay, they're a little taller than they are wide, but if you start to stretch them out, then they start to flatten out. So this is why your urinary system has this flexibility, especially in your urinary bladder. So they're transitional because depends on the amount of stretch. If they're stretched out, they look flat. If they're less stretched out and more relaxed, then they look taller. So that's why they call it transitional, because it can go between, the shapes are in transition. They can be variable. So not quite stratified cuboidal. And you often find these, and this is a classic thing. So again, that flexibility, that's why it doesn't quite fit into any of those three classic shapes. Now this one, ooh, all these four words that might be new to you. Pseudostratified cilia, columnar epithelia. And you're like, whoa, what was that word salad right there? Okay, so cilia are a cellular structure here. So cellular structure are these they're actually like little projections of these proteins and inside your cells, and they're actually able to move across like little arms that are waving things. So this is where you find these. You tend to find these in your respiratory system. Yeah, so then what we have here is the stratified cilia columnar epithelia and pseudostratified. So remember, strata means layer. Whenever you see this prefix pseudo, that means false. Like if you have a pseudo-intellectual, it's someone who sounds smart, but they're not actually smart. Or if you say it's a pseudonym, that's like a fake name you give to a creeper so that they don't track you down. And you say, oh yeah, by the way, my name is Kevin or something. Yeah, that's what pseudonym means. So pseudo means false. So it's not, pseudostratified means it's actually not stratified. What we see here, it looks like multiple layers of cells, but it's actually one layer of cells. So it's kind of like, I like to use this analogy. So what we have here is a line, and this is before social distancing. But are they in one line, two lines, or three lines? Yeah, it looks like they're in multiple lines, but they're actually in one line. So same with the pseudostratified columnar epithelia. They look like they're in multiple lines and layers, but they're actually all attached to the same basement membrane. It's just that they're so squished together that it looks like they're in layers. They're not quite actually in layers. So over here, so yeah, what the system I definitely want you to associate with this pseudostratified cilia columnar epithelia is the respiratory system. All right, so this is the way I like to think of it this way. So, and there are some other exceptions with the set where you find these transitional epithelia, but the one I definitely want you to know is definitely the urinary system for transitional and respiratory system for pseudostratified columnar epithelia. Those aren't the only places, but start with that. Yep. Okay, so you might be like, wow, how do I put this all together? So what I do is just kind of like build an epithelium and answer these in order. So how many layers does it have? Does it have one layer? Does it have multiple layers? Or does it have one layer that looks like multiple layers? So start off with that. Then does it have cilia at the very apical surface, the surface part of it? So this is where if it has cilia, you put cilia. If it doesn't have cilia, you don't say anything. Then you talk about the shape. Is it flat? Is it cuboidal? Or is it tall? Is it small, medium, or large? And then you end up with epithelia. So I like to do this like, my first job was at Starbucks, and when you do, so one thing, if you go to Starbucks and still order not using the app if you want to order in person, one thing that'll make your barista very happy is tell them whether it's hot, or you don't need to even say hot, you can say iced and then the size. So you say like, oh, I want an iced grande, or I want a venti. And because why? Because that actually tells them to grab the cup so that you can start taking notes. Then you can say like, okay, I want decaf or non-decaf, I want this flavor, I want pumpkin spice, I want 2 pumps of chai in addition to that. So you kind of have this order. Like if you look at the back of a Starbucks cup, it kind of tells you all the modifications you can do in order. So if you want to make your barista very happy, you can tell them what size and what modifications you want in order. That makes them like so happy. So that's same thing with the epithelia. So what you have is kind of like an order, and it's not just like random words put together. If you answer layers, cilia, and shape, and then add epithelium in the end, you have an epithelia.